Hi, I'm Tobia, an EPFL computer science student, and in this video I'm going to show you how some artificial intelligence methods can be used to solve a problem and reveal hidden patterns in a dataset. Nowadays, it is extremely easy to obtain large amounts of data about essentially anything. But this data is often not directly in the form that allows us to see what we want or answer our questions. AI methods and systems are perfect for transforming and understanding the data, but most people don't know enough about the topic to trust the results. My goal here is to try to explain what kind of things could be going on behind the scenes. Let's now go through a concrete example, and suppose we want to analyze university rankings. This might be interesting for students, researchers, and for the academic institutions themselves. There are many established university rankings that each year evaluate and rank the performances of academies all around the world. One such ranking is the Times Higher Education World University Ranking, which uses 5 separate performance indicators to rank universities: teaching, research, citations, industry income, and international outlook. The indicators are then aggregated into a score from 0 to 100, following a precise methodology. The result is the final ranking published on their website. This ranking is great to have an idea about which universities are overall better than others. But what if we want to look only at a subset of the indicators? What if we instead want to compare universities to understand their focus and policies? Looking only at the final score does not reveal this kind of information. Universities might have a similar aggregated score, but very different performance patterns in the 5 indicators. At the same time, looking directly at the 5 separate scores can also be problematic. It is difficult for a human to keep track of 5 indicators and correctly find similar universities. This is where artificial intelligence methods can be used to process and transform the data, allowing us to visualize the desired information. Since this dataset of universities has 5 scores for each item, we say that it is 5-dimensional. Such data is extremely difficult to visualize as it is, so we can apply so-called dimensionality reduction methods. These algorithms are able to bring high-dimensional data into a lower dimensional space. For instance, a space of dimension 2 would allow us to draw each university as a point on a 2D plot. Here, we have applied the t-SNE dimensionality reduction algorithm to our data. This method preserves the similarity between items in the transition from the original space to the lower dimensional one. Therefore, universities with comparable indicator scores will also be close in our 2D visualization. Now that we can visualize the dataset, it might be interesting to group universities into categories that have the same strong and weak points in the 5 indicators. We can already see on the plot that there are groups and regions of higher density, and we would like to detect the most meaningful clusters automatically. For this task, called clustering, there exists another family of AI algorithms designed specifically to solve it. One clustering algorithm that fits well the data is called the dbScan. It categorizes each point in either core points or border points, depending on how many data points we can find in its neighborhood. Then, clusters are constructed iteratively by taking points that are said to be density reachable by a core point. In this way, we can obtain and highlight all the meaningful clusters in the data that have a certain density threshold. Applying dbScan to the reduced university database results in the cluster highlighted with different colors in the visualization. Let's now explore a bit the visualization. Hovering on a data point will highlight the point and the entire cluster to which it belongs. At the same time, the name of the selected university and its scores in the 5 indicators are shown in the top left of the screen. On the bottom left, the so-called centroid of the cluster is instead displayed. The centroid is simply the mean indicator score of all universities of the cluster. It is useful to observe the centroid because it represents the common pattern found in that particular cluster. We can see by hovering multiple universities from the same cluster that their indicator scores will not differ all that much from the cluster centroid. From this, we can extract meaningful insight. For instance, we could conclude that all universities assigned to the orange cluster are strong in their citations and international outlook dimensions. In this visualization, interested users can explore the different universities and see their scores in the 5 indicators. They can look for universities that show a certain performance pattern, or they can start from an institution they know and find similar ones. The application of those 2 simple AI methods, namely t-SNE dimensionality reduction and dbScan clustering, allowed us to obtain meaningful insight about the strengths and weaknesses of all universities and see which ones are similar to each other. Artificial intelligence hence enabled us to obtain information that was initially hidden in the data. The same procedure could be applied to other fields to obtain similar results. That's it for this video, and thank you for your attention.